To all of you, myself, Dr. P.C. Tapre. Today we are going to the unit number 5, Unsymmetrical Fault Analysis, Lecture 1. The subject of this topic is Power System 2, and the subject code is 303148. The content of this topic is the first, symmetrical component; second, transformation matrix sequence component; third, power in terms of symmetrical component; fourth, sequence impedance of the transmission line and zero sequence network of transformer; fifth, solution of the unbalanced by symmetrical component, LL fault, LG fault, and double LG fault analysis of unloaded alternator and simple power system with and without fault impedance. And last point is the numerical based on symmetrical component and unsymmetrical component fault calculation. First topic is the symmetrical component. Due to the CL for secure in 1918, a set of n unbalanced phasors in an n phase system can be resolved into n balanced phasor by linear transformation. The n set are called the symmetrical component, or the second one of the n set is the single phase set, and the others are n phase or balanced. Here n equal to 3, which is given by the following cases. Symmetrical component definition: three-phase voltage VA, VB, and VC, not necessarily balanced with phase sequence ABC, can be resolved into three sets of the sequence component. First is zero sequence component. It is denoted by VA0, which is equal to VB0, which is equal to VCB0. Means the magnitude of the zero sequence component of the all phases are equal. Second is the positive sequence component, which is denoted by VA1, VB1, VC1. It is the balanced three-phase sequence is the ABC. And third is the negative sequence component, which is the VA2, VB2, and VC2, balanced with the phase sequence CBA. This is the phase sequence shown by the here. It is the zero sequence component. The magnitude is same and the sequence is 0. This is the positive sequence component, the ABC, the positive sequence component. And third is the negative sequence component. The sequence is the CAB. Now we can draw in the phasor quantity. This is the 0, VA0, VA1, VB1, and VC, VB1, and VC. It take the phase sequence and add the and calculate the total voltage VA. In the matrix form, we can show that the column matrix VA, VB, VC, and the matrix is 1, 1, 1, 1 A square A, 1 A square. The V0, VA1, VB, VA2, or V0, V1, V2. It is the zero sequence, positive sequence, and negative sequence. It is the total voltage of phase A, phase B, phase C, where A denotes the one magnitude of at angle of minus of one positive angle of 120 degree, which means it is minus 1 plus j root 3 by 2. Second is the VA, VB, VC. It is the matrix form in 1, 1, 1, 1 A square A, 1 A square, V0, V1, V2, where A denotes 1 at angle of 120, which means minus 1 plus j root 3 by 2. A square, which is equal to 1 at angle of 240, which is equal to 1 at angle of minus 120. And A square is A cube, it is equal to 1 at angle of 360, which is the equal to 1 at angle of 0. So A matrix, it is the 1, 1, 1, A square, A square. And VP is the phasor voltage VA, VB, VC. And VS, the symmetrical voltage is V0, V1, and V2. where V phase equal to A into Vs, or Vs is equal to A inverse V. We use voltage for the example, but the result applied to the current or any other phase or quantity. So A inverse, it is equal to 1 by 3, 1, 1, 1, A, 1, A square, 1, A square, where if we represent it by the current quantity, IP equal to A IS, and IS equal to A inverse IP, and VP equal to A VS, or VS equal to A inverse VP. So VA, which is equal to V0 plus V1 plus V2, means phase A voltage, it is equal to the zero sequence voltage plus positive sequence voltage of pole plus negative sequence voltage. Similarly, phase B voltage, it is equal to V0 plus A square V1 plus A V2. VC, which is equal to V0 plus A V1 plus A square V2. Similarly, we can calculate the sequence component V0, V1 and V2. V0, which is equal to VA plus VB plus VC by 3. Similarly, V1 equal to VA plus A VB plus A square VC by 3, and V2 equal to A VA plus A square VB plus A VC by 3. So these are the phase symmetrical or sequence component. The other phases follow since the sequence are balanced. So thank you very much for the today's lecture. Thank you.